start. Cool. And go ahead and post the attendance right there. Okay. Welcome everybody. Today is Wednesday, April 14th. I hope you all are doing well. If you feel comfortable, please go ahead and turn on your cameras because it always helps make it feel a lot more like a real class, but you don't have to if you don't want to. You've heard me say that 100 times now. So let's go ahead and get into it. So we have some announcements. These are basically the same as Monday, but just to reiterate, your homework 8 is due this Friday. That's the personal website. Make sure you get that done. The assignment will be made either tonight or tomorrow, and it'll just be like, you just have to paste your website link so we can go check it out. Check-in reports will be due next Monday. More information will come in a day or two about that. We'll send out an announcement. It's very low-key, just like one paragraph telling me what you have done, specifically you, not your group, but you, so I could engage how the groups are doing and who's working and who's not working. And then your final project presentations will be the 26th and the 28th of April. So that's 2 weeks away, not next week, but the week after. So please make sure you do that, work on your final projects. And presentation specifications of like what you need will be made available probably next week. We expect like a PowerPoint or like a Google Slides presentation and some other stuff, but more on that will come next week. So keep working hard on those projects. Ask for help if you need it. I've been helping several of you who have been reaching out to me personally, or for those of you reaching out to other instructors as well. I'm glad you are doing that. We appreciate the questions and we want to make sure you have the best product possible. Next week is the last week of lecture, so please come, especially on Monday. Emily is going to be giving a machine learning lecture, which is going to be fun. Learn a lot about like AI and machine learning stuff like that, which is super cool. Big CS brain over there. And then Wednesday will be kind of like a, we're not really sure what we want to do for that last lecture, but please come because it'll be like the last one. We'll probably like celebrate a little bit or something. And we'll do like feedback forms so you can tell us how awful we were as instructors. So please come on Monday and Wednesday next week. We'll really appreciate that if you can. And then attendance is right here. I posted in the chat like 20 times. I'll post it one more time just in case anybody needs it. But yeah, there. So is there any questions about any of that? Cool. All right, then. Let's move on to today's thing. We have one more thing. Well, one more tool, I guess you could say. Just like the name, or like in the words of Steve Jobs, we have one more thing. This last tool is called GitHub. It's super important for coding research. If you're ever going to be coding and working on like lots of code, or working with lots of code files and stuff, and you're going to have like a research group, chances are you're probably going to come across GitHub at least once or twice, if not all the time, because it's very, very useful. It's kind of like a very complicated version of Google Drive. So GitHub is this kind of like platform or service where it's hosted, like it's hosted by a bunch of servers on the github.com website. And like I said, it's like a really complicated Google Drive, but it's a lot more powerful. It allows you to host like all sorts of code and documents in one spot, like on a server in what's called a repository. We'll talk about that in the next slide. People can clone all of your stuff if you want them to. So like it's literally like copying and downloading all the stuff that you are comfortable with them doing that. So there could be like a whole repository or folder filled with like simulation codes and like other notebooks and stuff that they've worked on to make like this package or whatever. You can download all that to your own computer, even if you don't really know them. As long as it's public or whatever, you can download all that and you can clone it, make a direct copy that won't affect any of their files, which is really nice. It can host more than just code, like documents, PowerPoints, Jupyter Notebooks 2, which is a little bit of code, but it's a little more complicated than just a coding file, and it holds code, like I just said. So it's very versatile. It can hold tons of different things. And it can be used to make websites. I don't know if anybody in our DeCal is actually trying to do that. GitHub.io makes really cool websites. or allows you to make really cool websites. It's a little more complicated, but it's very useful and very cool. And and once you learn how to use GitHub, you can learn how to use their website service that you can make websites with. And what makes it probably the most powerful thing is that you can track individual changes made by anybody, and you can revert back to them. If, say, somebody, you're working on like a giant thousands of lines of code on a file, and somebody wants to add or change a couple lines of code to it, and it ends up breaking the entire thing. Like you had a perfect simulation, or it was almost perfect, and then somebody just like went ahead and screwed it all up, but they didn't like tell you exactly what they coded, and they're not responding or whatever. That's okay. You can revert back to that, to the form before they edited it, and you can actually see exactly what they edited, and you can debug and figure out what they did wrong. And that's kind of one of the things that makes it so powerful. And you can do that with lots of people editing the same file. You can check and go revert back to previous versions and histories of the files in the repository before anybody else edited them or after they edited them, which makes it very useful. And it's typically used in the terminal. So, or like that's the easiest way to access GitHub or to use GitHub is use Git through the terminal. So, what is a repository? Well, it's a collection of documents, codes, slides, etc. And it can be added to or removed from. And it can be edited. It's kind of the same thing as added or removed from, but it can be edited. And just think of it as like a giant folder that you can access and put stuff in, or you can remove stuff from. But this folder saves every version of what you edited or what you edit. So it doesn't explicitly have like tons of files that visibly you can see that's like every single iteration of it, but internally in the back end, it keeps track of everything for you. So you can revert back to them if you need it, which is very nice. So what's a remote versus a local repository? Well, a remote repository is hosted by the GitHub servers, like at github.com, and it can be accessed by whomever is given access. So that could either be public or that could be made private, depending on like how you care about your, or like how you feel about your access to your repository. If you're working on cutting edge research that might win a Nobel Prize, you probably don't want everybody to be snooping around it, especially if they're in your field, because there are some sly, sneaky people out there. So you might make it private and only allow certain people to edit it. Or it might be made public. Maybe you have a software package that you've written that you want people to use. Then you would make it public so anybody can use it. And typically we can copy and download this repository to our own computer. So we call it cloning. You can clone that repository onto your own computer and work on it as if it's a folder in your laptop, which is really nice. And that becomes a local repository. So local repositories it's like it becomes a directory on your very own computer. That's what a local repository is, but it's connected to GitHub. So GitHub is still keeping track of it, but you're working on the local repository on your local machine. That's what makes it a local repository. So it's accessible through the terminal or GUI, that's GUI. It's like graphical user interface, meaning your mouse and keyboard. But typically you almost always access it through a terminal. You should be getting really good at that. If you ever do decide to start using GitHub or Git, it's very good at making sure you become very proficient at using the terminal or the command line, Unix, all that stuff we covered at the very beginning of the semester. This is a very good exercise for that. So usually your work is done on your local computer through the terminal, and any changes and adjustments made are then you can stage them and send them to a repository, to the remote repository. So you do work on your local repository, you stage and send it to the remote repository. But you might be wondering, what does that mean? What does stage and send mean? So I have a little diagram that I found online. But first, how do you use GitHub? Well, you use it via the command line. I've said that like 20 times now. And I made a diagram that will show you how to use GitHub. But first, we need to review, because I'm pretty sure almost nobody remembers Unix commands or how to work with a command line. So we're going to go into breakout rooms. And I want you guys to remember what CD, PWD, MKDIR, and LS do. And I will be asking for people to answer this after we come back. So please make sure that you talk about it, because I will be either calling on people's names or asking for volunteers. So no pressure, but pressure. Yeah, so we're going to go into breakout rooms. And then when we come back, we'll get into how GitHub works a little bit more visually. So let's pause. Okay, so welcome back everybody from the breakout rooms. Would anybody like to go first for as many of these as they want, or one at a time? It doesn't matter to me. But would anybody like to tell me what these commands do?
CD is change directory.
Fantastic. Thank you very much. Anybody else want to volunteer for?
Yeah, PWD is print work directory.
Beautiful. Thank you very much. Anybody else want to volunteer for the other ones?
MKDIR is make directory.
Sweet. Cool. And then LS, anybody want to give me LS? It's okay if you don't remember what it stands for.
It's list.
Yeah, I actually don't really know what it stands for, but it lists everything. So yeah, that's good enough for me. Yeah, LS is like the list command. I don't really, does anybody of the instructors know what LS actually stands for? No? Okay. Well,
I think it's list files.
list files? Well,
I mean, LS doesn't really.
yeah, right. Like I don't know why anybody picked L. Anyway, we know what it does, and that's what's important. And you do these in the command line, right? So that's what's important, is that you're using these in that big terminal type of screen. So you type them here, like after your like this little command line. You can access files in your computer and make new directories and put files in your computer on the terminal with those commands. So that I'm glad we kind of like worked our brain a little bit to try and remember what that stuff does, because you're going to need it when you're using GitHub mainly, or Git repositories. So how do you use GitHub? Well, this is kind of like a diagram of how it all works. So I think I can do a laser pointer. Yes, I can. So whatever directory you're working in, this is like a file on your computer. You're usually like in it in your terminal or whatever, or your command line. You're working in some sort of folder on your laptop or your computer. Then let's say you want to push, you want to put a file or whatever you're working on, you want to upload it to this remote repository on the server so that it's saved and everybody else that is not on your laptop can use it. Maybe it's like everybody that's in your research group that wants to take a look at your code or whatever it may be. You want to push it from the working directory all the way to the remote repository. How do you do that? Well, first you type what's called git add. This is, you add all the files that are relevant. So you specify what file it is you edited, and then maybe it's like a Python file, maybe it's a bunch of files. You can put multiple of them. So you add these files to this what's called a staging area. So I like to think of it as you're like, I don't know, I kind of think of like your computer as like a maze, right? And then when you're ready to send like a file up to the cloud, you have to stage it first by lifting it up above like this leaf maze that you're standing in. So imagine like putting a file like up above your head, and it's kind of visible to everybody else above the maze, and then you have to commit it or like once you've staged it, you've added it to the stage so that GitHub sees it and knows that it's a file that's ready, that you want to eventually put at the remote one, or move to the remote repository. Once everything knows that by staging it, by writing git add, then you have to commit that file to the repository itself. So you add via Git, and then you have to commit via Git. Committing, I don't get why it's like a two-step process, but you can add multiple files to the staging area, and then once they're at the staging area, you can then commit them to the repository. So once you commit them, they're part of your local repository, and the directory you're in isn't necessarily the repository itself on your computer. The repository is this, it's like a directory that's keeping track of everything. Git is specifically keeping track of all the files, history and stuff, and that's kind of what makes it the repository. It's like a super special folder, right? Or a super special cluster of files and stuff that GitHub is keeping track of on your laptop. That's the local repository. And then when you're ready to push, so now you can still do version control and stuff, and you can go back to previous versions if it broke or whatever. It's still through GitHub, but you haven't moved it to the like online server yet. You haven't made it available to everyone else of your colleagues. or everybody else in your colleagues. It's only available to you on your local repository, hence it's local. So in order to make it available to everybody, you then have to push it by writing git push, and you git push that you get pushed to the origin or your main branch or whatever it is. There's branches to your repository. You push to the main server by writing git push, and then like I think it's like origin main or something like that. You can look it up in a tutorial, but whatever the command is, all it's doing is taking the files from your repository, your local one, and putting them remotely available to everybody else that can access the like remote repository on github.com. And I'll show you how to do that in a working flow in a little while. And then if you want to pull a file from that remote repository that's available to everybody, let's say you're the colleague now and you want to bring the file that the other person just edited, you want to bring it on your laptop and start using it. Well, then you just do git pull, and you pull that file to your own repository, and then it's available. So it was at it started at the working directory on somebody else's laptop. They staged it, they committed it to the repository, the local one on their laptop, and then they synced it up with the remote repository by doing git push. The remote repository is the one on like github.com that you can go on the internet and find. And then if somebody else wants to pull that same file on their laptop on the command line, they write git pull to the like they go inside of their local repository, they git pull, and it brings those files from the remote repository. It brings everything that you want to your own laptop, the repository that's hosted on your laptop, and then you can git check out and bring it to like the working directory. I know that's a lot, and that's like super annoying to like see all this stuff, and you have no idea of how it works. So we'll talk about how it works in a demo in a little bit. And I just thought I'd put a little Yoda meme because you can't not put a Yoda meme for something that says push. So you got to push it to anyway. I think that's funny. So how do you like use it in depth? Well, I'm not going to talk about that because I'm 95% sure that if I talk about it too in depth, nobody's going to actually retain it. It's going to be wasted time. And I don't want to waste your time, and I don't want to waste my time. So I'm just going to boil it down to like 5 commands that you just should remember about Git, and that's these. So git clone is how you copy an entire directory or entire repository to your computer. Git clone, and then that will bring like an entire repository that you want on your laptop to use, and now that becomes a local repository that you're working with. Then git add is how you first have to add files that you want. If you want to push them back all the way to the remote repository, you have to add the files, and then you have to stay like to the stage, and then you have to commit them. That's git commit. So those are two commands right there. Git add, git commit is how you get it ready to you add to your local repository once you've edited it, and then git push is how you send it back to the remote to the server, and then git pull is how you bring new changes back to your laptop. It's really complicated, and that's why I recommend the only way you'll actually learn this stuff is if you do tutorials. So I recommend doing this tutorial right here. It's very, very useful. It's for like novices. Start from the very beginning. How do you get it set up on your computer? How do you work with Git? Like on like it shows you several examples. I highly, highly recommend doing this on your own time. It's not going to be a homework assignment or anything because it's very optional. But if you ever want to work on like large research projects, I highly recommend doing this on your own time. I think it takes like maybe an hour, 45 minutes to do the whole thing. And it'll help you greatly to do a GitHub tutorial. There's also a basic guide that is very similar, but a little bit more complicated. I recommend doing both of these, honestly, if you can. And then this is like a GitHub handbook. I wouldn't really read it, but I linked it there in case you wanted to find something in it. It has lots of extra details that are not really important. But the GitHub novice step-by-step tutorial is super useful. So I would highly, highly recommend doing that. Cool. Now I have a demo. I just want to show you how you do this in practice. How do you use GitHub in practice? So I'm going to switch gears over to my terminal. Can everybody see the terminal? Sweet. So just for a clean slate, where I'm going to start at my desktop. If I press LS, it shows you all the files and all the directories and whatnot in my desktop. So I'm going to make a new folder. We're going to call it demo. So now you should be able to see demo folder. Where is it? There it is. There's a demo folder on my desktop directory. And I'm going to go into it by saying cd demo. So now I'm in my demo folder. There's nothing in it yet, but we can make something happen, or we can add something there. Now, let's say I want to clone an entire repository. Maybe there's a software package or something that I want to clone into my folder that I just made. So how would I do that? Well, now I have to go back to the internet so I can find a repository that I want to look at. So I'm going to start sharing this again. So let's say, let's go to github.com. So this is GitHub. You just type in GitHub. I have an account. So I signed in. This is my profile. I have different repositories that I've made, yada, yada, yada. You might notice, hey, there's a Python DeCal repository. Oh, that's interesting. Oh, it has lots of folders and files with homework and homework solutions. Oh, wow, that would have been really nice to know. See if you knew how to use GitHub before the class started. Huh? But now you know how to GitHub works. So, well, I mean, you don't know how it works yet, but I'm showing you how it works. And so I'm actually going to clone this Python DeCal repository on my own laptop so that I can take all the solutions and the homework files and have them available to me. So how do you do that? Well, you find this repository, and if it's publicly available, which this one is, you go to this code button right here, and it gives you a clone option. So you can actually copy. This is the like HTTPS like link. It's like a GitHub link to this specific repository. This is how when you do git clone, it knows what repository you want. This is how you specify what repository. So what I'm going to do is I'm actually going to copy it. This little button allows me to copy that whole link. And then now if I go back to my terminal, I can, now that I'm in my demo folder, right? I'm in the demo CD or demo directory / folder, whatever you want to call it. Now I can do git clone. And then all I have to do is paste that repository or this repository link, this HTTPS link. And what that'll do, if I press enter, it clones the entire DeCal repository on my laptop. Depending on how big the repository is, depending on how many files there are, how big the files are, maybe there's videos and crap on there. There's going to be a lot of stuff to clone or a little stuff to clone if you're just starting one out. So don't worry if it takes a little bit of time, but you'll see cloning into Python DeCal. It counts all the objects and it brings them to your folder. So now if I press LS, before it was empty, but now I have this Python DeCal repository inside. So now if I cd into the Python DeCal, just to be clear, everybody can see my terminal, right? Sweet. So I cd into this Python DeCal terminal. Now I have all that stuff that was available on the website. So if I wanted to access the homework solutions, say for this semester, spring 2021, I can go into that folder, press LS. I'm going to clear the screen because it's a little messy. So inside that homework folder, or inside that spring directory, I have the homework folder and the resources folder. Let's say I wanted to go into the homework. Lag. Okay, now I'm in my homework folder and I can go to whatever week I want. Maybe I want to go to week 5 or 6. We do week 6. Man, it's like really slow. What's going on with my laptop? So going to week 6, and then hey, what do you know? There's the homework 5 notebook and there's the homework 5 solution. So if I wanted to, I could press Jupyter, I could type Jupyter Notebook and it'll open up Jupyter Notebooks and I have access to all those files. And I pulled them all from my directory or from my or from that repository online, which is pretty cool. So now if I go all the way back up to the Python DeCal, or actually we can just leave the directory entirely. So now I'm outside of my repository. I'm completely outside of that repository. I cloned it successfully. Now it's on my laptop and I'm using it. Now it's a local repository on my laptop that I can go work into. Now, if I want to say, make some changes, let's say I wanted to add a file, I can go into this folder called demo. Oh, never mind, demo is not a folder, but I can make a folder, demo 2, and my laptop is super laggy, man. Why is it so laggy? Anyway, I could cd into demo 2, and now this is an empty folder. And let's say I wanted to make a new file. I'm going to use a text editor called Vim just to make some random file, and I'm just going to say test file dot text. So Vim is just a text editor that you can use in the terminal. Don't worry about it too much. But I'm just making, all I'm doing is making a text file to show you. And I can go right. This is a neat little test file. Howdy. And then I will save it. Now if I ls and I look what's inside of this folder, there's a test file in there, and we're good. So now I left that folder and I'm in the main repository. I'm in my local repository. I added a whole folder and a file inside of it. So now how do I push it to, how do I send it back to GitHub so that other people that use the Python decal like Isla, Emily, and Raphael could see it? How do they go to see it? Well, now I have to send it back. So what I'm going to do is I'm going to say git add, and I'm just going to add everything that I added. So I'm just going to say git add demo 2, and star means put everything inside of demo 2. Actually, I think I could just do demo 2. Yeah. So I just added the whole demo 2 folder, and it should have the text file that's inside of it. Now, if I want to see if it actually got added to the stage, I could type git status, and you see, hey, there's a green little file here, new file, demo 2 test file, or so there's a test file.txt inside of this demo 2 folder. I've added it to stage, and it's ready to be committed. So it's saying changes to be committed. I added this new change. This is the new thing available in this repository that I want to send to the remote one. I added a new file in my local one, and I wanted to send it first to the local one and then to the remote one. So now to actually finalize it, take it off the stage and put it in the repository, I have to do git commit. I have to commit it. And then this -m is just short for like a message modifier. So I'm just writing a message so I know what it is. This modification was on for, what's this today? 14 for DeCal. So I just made this little note to myself so that when I go to look through previous versions, I know that this is like what I was doing. It helps me keep track of it. I commit it. So now it's part of the repository on my local machine, but I want to send it to the remote machine. So now there's only one step left, and that's git push, right? So all I have to do is git push. And I think to send it to like the original main branch, like the main repository, I do like origin main or master. I think it was made before the change, so I think it's master. So I git push. All I'm doing is git push, and then sending it to the origin, the master branch, and then give it a second, and boom, now it's all pushed. So if I did everything correctly, we should see a new folder available on the website. So here is the repository. You can see Python decal. This is what it looks like before. And then if I refresh the page, hopefully it works and I know what I'm doing, we should see a demo 2 folder. Boom, there's a demo 2 folder. So what I did was I cloned the whole repository to my laptop, made a local repository of the remote one, but I made it local now on my laptop. And then I added some files, and then I staged it by adding git add, and then I committed it to the repository on my laptop, and then I pushed my local repository to the remote one all the way over on the server. So now if I'm a colleague, I want to look what's in that test file, I can see exactly what happened. Okay, so that's kind of like a working flow. And then similarly, if I wanted to make sure that let's say my other colleague added some files, all I would have to do is write git pull, and it should just pull everything. Yeah, so if there were files to pull, it would do a bunch of scanning and like pull it back onto my laptop, but there are no new files because nobody added them. But it tells me it's already up to date, so it's all good. It's all good. So now I've kind of shown you all of the basic workflow that I use on a daily basis, and that's kind of like a very top-down level. I know that was really a lot in like a matter of a few minutes, and I totally don't expect you to understand all of it, actually much of it at all. You will understand it though if you do that tutorial that was on the slides. So I can't stress that enough, that you make sure you do that. Is this the, yeah, that you make sure you do this work, like this tutorial right here. I highly recommend that. I'm going to post the slides as soon as lecture's done. You can go take a look at that when you have time, either after the semester or maybe during, or maybe like tonight if you have time. Whenever you have time. I can't stress this enough to you. This GitHub is like one of the most important tools for coding, especially if you're going to ever code with other people. You may have found for those of you in group projects that coding with other people is kind of a pain in the ass. This is, if you could get good with GitHub, this makes it a lot easier, a lot easier. And if you're really fascinated by GitHub, you can take 61B and actually code it up yourself. Like a Git, you can like write Git yourself, which is crazy. I don't even want to begin to think about how you do this yourself. But that's everything I had for you guys today. I hope it was interesting or semi-useful. Please come to lecture on Monday for a machine learning lecture. It'll be kind of like a special topics one, so it'll be super cool. Machine learning is kind of like changing the world. It's very cool. You can teach a computer how to teach itself. And then Wednesday will be like our last lecture. So please everybody come. It'll be pretty short. I don't think we'll talk about much. But yeah, Wednesday will be our last lecture next week. So please come for both days if you can. Yeah, good luck on your homework 8. Do this Friday at midnight, and I'll see you guys next week.
Thank you.
Thank you. Before you go, can I ask a question on that final project I was talking about earlier?
Yeah, I saw your email. Sorry, I didn't respond to it right away.
No, that's okay. I wasn't really sure. I was trying to solve A1 and A2 on paper, and it was just getting really complicated.